Hey folks, the other day I was just looking through eBay and I had become rather enamored with the inverter technology, inverter type generators, and I happened to see an ad for this WEN generator. This unit is a 225, a 1800 watt rated unit, and well, I'd always thought the price was for these inverter generators was above what I really wanted to invest in. This one was listed for $299.99 plus about $63 for shipping. And before I could control my digit, I found that I had ordered the thing. And so the other day it arrived, and what you see sitting in front of me is the unit. Now, who is WEN? Well, WEN apparently was started in about 1951, and the company is located in Elgin, Illinois, and also goes by the name of Great Lake Technologies. Now, apparently they specialize in all kinds of tools, including generators, and they sell these tools, well, they have these tools produced overseas for them, and they seem to specialize in getting inexpensive tools, or a variety of tools, shall we say, at a relatively inexpensive price by having the manufacturing done overseas. When I looked on the Better Business Bureau in Elgin, Illinois for this company, I found that the company Better Business Bureau listed them with an A- rating, which I was very much pleased with. They have a website in which they include a great deal of parts that you can purchase through the company, through their website. And so I kind of perused through their parts list. One of the great fears I have with the inverter generator is if you lose the inverter, it's kind of like a piece of junk if you can't find a replacement or a reasonably priced replacement. Their modules, they did not list a module for the 220i, but they did have a modules for the 2000 series units, and the price for their modules was running about $106 to $170. So I was pleasantly surprised. Not cheap, but certainly not outlandish. Okay, a little bit of information here from the owner's manual. This unit is rated at 1800 watts with a peak of 2250, and it has 120 volt output. It does have 5 volt DC output for electronic equipment, and it has 15 amp outlet for your AC. The unit weighs 48.5 pounds. We've got a 4-stroke overhead valve engine, and the displacement on the engine is 79.7 cc's, and the tank holds 1.19 gallons of fuel, and it has 11.8 ounce of oil capacity. It supposedly will run 6 hours at half load. And now we might, well, the noise ratings are really supposedly pretty good, 52 dB at no load and up to 57 dB at 3/4 load. For those of you that are interested, and frankly I have some interest in these sorts of things, is the basic wiring diagram of the of the unit as shown here. The alternator is a three-phase device, and it appears that it's got a separate winding for the DC output, which is shown here, and the big device here with M in it is a stepper motor for controlling the engine speed. The ignition, it has an external ignition coil. They call it an igniter on this diagram here, and this represents a spark plug, and then it's got a manual shutdown switch. You hold this button if you want to kill the engine. And apparently it picks up from the flywheel a signal which both energizes the coil and tells the unit when to fire the spark plug. The other, this is the inverter board here, and this is a connector going to here, and this is the 120 volt output AC receptacle. Also here is shown the two connectors for the paralleling feature, and as you can see, there's no special feedback feature as far as I can see. I don't know that you need to buy their paralleling cables unless you really want to in order to parallel with this with another unit. It's just pretty much a matter of plugging the two units together. Again, that's my opinion, may not be fact, but so that in a very simple way is the basic electrical wiring of the unit. The other item, I noticed that the parts were sort of interesting. They have a whole series of these units. This is from their website. They've got a 1600 watt unit, rated output up through 1900 watts, and this 5600 series unit. And all of these use the 79 cc engine and the 1 gallon tank. It's sort of like these four units are pretty much all based on the same frame, and I suspect the difference in the two and the four may be basically the rating of the inverter and a few other specialty parts. In fact, if you look at a typical breakout page, I noticed that the catalog numbers for a lot of the parts start out 56200, but what is different, this is the inverter module, item 12, and it's 56225. So you kind of get the idea that the 5600 series uses the same plastics, most of the same parts, except for the very specific models then have modules and so forth that are just for that particular unit. Okay, Waddell, what did I get in the box? Well, first of all, let's talk about the box. And of interest is it says that this unit was made in Vietnam. So, you know, I assume probably our Chinese friends are really the manufacturers of the unit, although it may have been assembled and packaged in Vietnam. Here you see one of the covers removed, and what was included in the box was a funnel, the owner's manual, and tools including Phillips straight and straight blade screwdriver, an 8 and 10 millimeter open end wrench, and a spark plug wrench. So I think perhaps where we're at now is, let's take a look at the controls on the front of the unit. Starting at the top of the control panel, we have 3 LEDs. The first one is, when illuminated, indicates low oil condition. The center one indicates a overload situation, and finally the third one indicates a power output. And the low oil light is yellow, and the overload is red, and the power output is green. On this side of the panel we have a 3-position switch. When starting, you'd rotate it down to choke, which of course sets the choke position. Once the engine is started, then you rotate it up to run position, which takes the choke out of the operation. And finally, it has, if you rotate it to the top, it's an off position. Now, this actually shuts the fuel off to the carburetor, so the engine will continue to operate for a few minutes because of the fuel in the carburetor. However, if you want to make the engine shut down immediately, you can press this manual shutdown control and hold it, and that will ground out the ignition. Now, if you get an overload situation, now, if it's approaching overload, this goes through a sequence of perhaps flashing, but if it goes solid and then shuts the inverter down, you take the load off the unit and press this reset button to reset the inverter and hopefully get everything back up online. In the center of the control panel, we have 2 USB 5-volt outputs for charging electronic equipment. And below that is connections for paralleling cables, so that you could run cables from these 2 outputs to a second generator and parallel the 2 so that you could operate them in parallel. Of course, here is the standard 120 volt AC receptacles, and the grounding lug is located here. Finally, but not least, is the econo mode switch. In the off position, the engine just runs at full speed continually. If it's in the on position, then the engine is allowed to rise and fall in speed as needed to meet the electrical load requirements, and this results in a good deal of fuel saving. Now, the manual recommends that if you have this on, you should have an electrical load of 350 watts or less. And the problem is, of course, is if you have this on and you hit this with a 2,000 watt highly inductive load, let's say something like a motor, the engine may bog down and die and not be able to recover. So when you think your load may be above 1,350 watts, the manual recommends that this switch be left in the off position. Okay, well, we'll put some fuel in this unit. It hasn't been started as yet. I kind of off camera, I filled the crankcase with oil. Also took the spark plug out and put a few drops of oil in the top of the cylinder head. So, assuming this unit starts, it'll probably smoke a bit at first. And I've got about a half a tank of fuel if you want to take a look at the fuel gauge here. right, let's see. Next step is to make sure I've opened the vent on the gas tank. It does have a valve to keep fuel. I suppose if you should turn it over or something while you're transporting it, it helps to keep fuel from leaking, and also helps to control evaporation from the tank. Now I've just turned the three-way switch here to choke. Hopefully the carburetor is filling with fuel. Like I said, it hasn't been started yet, so it may be a little dry and temperamental. And let's see, I've got the choke on. Actually, as far as I know, it should be ready to start. I'll give it a couple of pulls here and we'll see what happens. Well, that was certainly easy enough. As you can see, I've got also put a tachometer on here. It says that we're running about 4,650 CFM at the moment. RPM, excuse me, not CFM, RPM. Now I'm going to switch the Econo switch. And it drops down to 3,320 RPM. All right, just for grins, I'll flip that switch back up again and see if it comes up to about the same place. All right, well, around 4,700 RPM. Well, I think it certainly passed the starting test. I guess the next phase is we'll need to load this unit up and see how it acts under load. Okay, this part of our video, I'm going to attempt to do a load test on this generator. On the floor is a box that contains a bunch of heater elements, and by operating these toggle switches I can vary the load on the generator. We'll start out fairly low and just make our way up and see how it does under load. I've got an oscilloscope here which should show the waveform coming off of the generator. We've also got a power monitor here which will give us the amps and kilowatts and voltage output. It also has a small readout that indicates the frequency. I would say ignore that. It's just a flag really. It either flips to 50 or 60. It doesn't give the exact frequency. And last but not least, I've got a small inductive tachometer here so we can keep an eye on the engine speed. And I guess we'll go ahead and start now. This unit has a blower on it. Of course, I'll have the engine running. I may not have a whole lot of commentary. Even though this generator is really quiet, we're inside a structure here, and a structure with a big overhead door open, incidentally, so hopefully the buildup of carbon monoxide will not be an issue. But we have a couple of noise makers here, so I may not have too much commentary, but basically what we're going to be interested in is seeing how the unit acts as it loads up. And I'll go ahead and get the blower started. Now the blower is powered from a wall receptacle, so the power for the blower motor does not come from the generator.
Since we're going to take the load up fairly heavy, I'm going to leave the eco switch in the off position. Just double checking to make sure the vent for the gas tank is open. Plug this in. And we'll see how we're doing here. Okay, now we're just starting the load test here. And we've only got about 155 watts on the load on it. Our voltage is 123. 1.26 is the amperage, and again I will pay no attention to the kilowatt hours, or this is on another machine, so it was the kilowatt hours mean nothing. They will add up kilowatts that we have on here, but this was accumulated. This is a total where it's on another machine, and again the frequency, the 60 hertz, is just a flag, an indicator. It'll either flash 60 or 50, and it's just an indication of what frequency system you're on. Now I'm going to go ahead and bring this load up a little bit. Now we're at 174. Now we're at 233. Now we're coming up to 280, almost 279. It keeps climbing. We're at 350 now. Hardly noticed any change. What's our RPM doing here? It's still at 46. Well, of course, it's running pretty much straight out because we don't have the econo mode on. All right, now I'm going to go into a paralleling mode here. This will bring, tell by the sign of the sound of the engine, we are bringing on some of the load now. We're up to 670 watts, 715, still climbing, We're at 880 now. We just went to 1,100. We're now at 1,290. Again, you can tell that the engine is starting to labor a little bit. And we're at 1.83, just a tiny bit overloaded. And this is an 1,800 watt machine. We are getting an indication that we're overloaded. Going to back off just a little bit. Overload light went out just like it was supposed to, and we're now at 1,290 watts, 1,300 watts. We're going to take the load all the way back down to minimum, and let's see how it acts with the econo mode on. The engine slowed down. Looks like we're running about 3,440 RPM. And I'm going to just bring the load up again and see how the throttle responds with increasing load. still no change. We're at 100 and we're hitting about 200 watts now, still nothing. 233, I can't tell the difference. Tachometer, I wasn't watching that closely. It looks like it's sitting on, what is that, 3,500? Maybe it has climbed just a little. We're now at 280 watts. Not a noticeable change in the speed. We're now at 3,400 watts. I'm sorry, 347 watts. RPMs still at 3,500 RPM. All right, we're now at 459, and looks like it has bumped the speed just a little bit. It's up to about 3,700 RPM. I'll back this back off. We'll go into paralleling mode and get a little more load on it. Now we've climbed to 672 and we're at 3,900 RPM, so it's starting to climb. All right, 716. Now we're at 780. Where I'm having a little trouble reading that. What is that? 4,700 RPM? Oh, 4,000 RPM. Had to look at the camera to see what it was. Now we're at 800 RPMs. Have climbed just a bit more, almost 4,200, 4,170. Going on up. Now we're at 1,100 watts, and we're running at 4,460 approximately RPM. Now we're really starting to make the machine work. We're at right at 1,300 watts. And 4,780 RPM, and the next one should take us into an overload situation. And the engine has climbed to right at a little over 5,000, and it is swinging back and forth a little bit. So I'm going to back the load off a little bit. Everything sounds really good. The waveform looks good. It's sitting there running very smooth. So I'm going to proceed now to shut down. I think everything really looks good on the load chest.
Okay, we've got, just to do a little sound test here. I'm just using an app on my iPhone, so, you know, we've got birds in the background singing, and we're away from any buildings, but, and probably the occasional jet airplane going overhead, so, you know, this will just be kind of an indication. Might kind of zoom down and show the folks what the background is down and get the background here. I'll shut up for a second or two. Maybe our Katie will shut up for a minute, but I doubt it. Anyway, let's start the engine up and see how things go here. Okay, now we've got it on with the econ mode on. The tachometer, let me check here. Tachometer says that we're running about 3,300 RPM, and we'll just go ahead and take the econ mode off and see how the noise level comes up then. Okay, now we're running at 4,650, 4660 RPM with the econo mode off. Now, if that looks pretty good, we'll just end the test there for right now. All right, now just as a comparison here, I'm going to compare. This is a Westinghouse. It's got a synchronous type generator with a 212 cc engine on it, and camera person, you want to zoom in on the noise level background. We've got cicadas and everything else out here, so it does bounce up and down quite a bit. All right, let's go ahead and see if we can get this rascal up and going. Okay, well, now that gives you some kind of a comparison. It's not hardly fair, but this engine is a bit bigger than the other one. I was going to try it with my little Sportsman, that has about the same displacement, synchronous, but when I tried to start it, it had a carburetor issue, so I guess it was disappointed it wasn't being the star of the show this morning. So with that, we'll shut down our sound check routine for the moment. Well, we're going to try to attempt to do a fuel consumption test here, and what we're going to try to do is put in about 24 ounces of fuel, run it for 20 minutes with approximately 1,000 watt load on it, and then shut the unit down and check to see how much fuel that's consumed and compare it to the manufacturer's consumption figures. So there is 16 ounces. Issue. So I need another 8 ounces of fuel. So that should be 24 ounces, assuming I get it in the tank without spilling it. too bad. So we have very little fuel in here. Hopefully we'll be able to run this for, let's say, 20 minutes without running out of fuel. And if that turns out to be a problem, well, we'll just have to try again. Let's see. Got the choke on. We have the breaker on. We have this preset to give us right at 900 watts of load. Let me clear my stopwatch and we'll go ahead and start the cooling fan on the heat load. Looks like we're running right just slightly over 900. RPMs are 51, 5200 range. Everything looks good. So now we're just going to let this unit run for 20 minutes and then shut it down and measure how much fuel we can get out of the tank after that. We're just rocking this back and forth, attempting to get the last bit of gasoline out of this tank. It's fairly flat on the bottom, so yeah, the bottom's wet, but I don't see any standing gasoline. I think we've pretty well got it out. And this is 8, 9, 10, 11. I'm going to call it about 11.4 ounces plus floor. So that's 15.4 ounces that was taken out of the tank. Here is the results of our load or fuel consumption tests. We installed 24 ounces of fuel in the tank, and we were able to drain back out 15.4 ounces. So in the 20 minutes that we ran this, it consumed 8.6 ounces. So the fuel consumption per hour, if take 60 minutes and divide by 20, that's 3 times 8.6, so that's 25.8 ounces of hour of fuel consumed. Now this is our theoretical consumption based on our test. Now the manual says that the unit at half load, which is about what we were running at, will run 6 hours at half load, and that the tank holds 1.19 gallons. So if we convert this into fuel consumption per hour,
We take 1.19 gallons, divide it by 6, times, there's 128 ounces in a gallon. We get 25.4 ounces per hour as claimed by the manual. And our test was 25.8. I would say that certainly within the error of our capabilities here to measure consumption, we've verified that what's claimed as being a consumption rate in the manual turned out experimentally to be just about right on.
What I like about this unit, it delivers what is claimed by the manufacturer. The inverter technology produces a beautiful sine wave output and is very stable. The inverter technology allows paralleling for higher output power. The noise levels are quite low as compared to open frame generators. And one of the really nice features is that the price of this unit is about a third of the listed price for a similar capacity Honda. The warranty for this unit is 2 years, and some of the more expensive units offer a 3-year warranty. The Honda uses a 120cc engine, while this unit uses a 79.7cc engine. The larger engine may mean that more horsepower can be delivered at lower RPM, which may mean that the WEN generator runs at a bit higher speed, which could result in shorter engine life. So far, I'm just delighted with my purchase, and it seems to be an excellent value for the dollars spent. Thank y'all. I hope you enjoyed the video.